Hi everyone and welcome back. So here is our last video here for the week before you have your quiz on Friday, which is going to be on Delta Math. Just remember, for the quiz on Friday, you'll have an hour for it. You'll only have one try per question, and that's going to be going in as a grade on Power School. Okay? So I want to continue with where we left off. We were talking about quadratic applications in the real world. So right now I am on page 31 in your packet. So let's take a look. The first question we have here is a rectangular garden, measures 12 meters by 16 meters, and it's to have a walkway installed around it with a width of X meters, as shown in the diagram. Together, the walkway, so we have the walkway and the garden, have an area of 396 square meters. Okay, so this was from the June 2014 regions. This question goes down in history. You can ask any of my algebra students about this from last year. All right, so let's get started. We want to write an equation, that can be used to find x, which is the width of the walkway. So we want to write an equation that's going to help us find x, which is the width of the walkway. So remember, and if you need to, guys, go back and read. We have this rectangular garden here in the middle. So I'm actually going to highlight over that for us in green. So here is the garden, okay? All right, so I outlined the garden for us in green. And now the next piece we have is that this walkway is being installed around it. So I'm going to highlight around that in yellow. Our walkway is being installed around it. Okay, and again, we want to come up with an equation. Equations have equal signs. That's going to help us find x. So, you guys, we got to brainstorm here. Let's think about the entire area of this whole thing. We know the area of the walkway and the garden is 396 square meters. So that means this entire area is 396 meters squared. You're including the garden with the walkway. So that's that entire total area. Okay, so I highlighted that entire garden, including the walkway area, because we know the area of that to be 396 meters squared. Now, if we can come up with the dimensions for either side, we'll have our equation. So you guys, we have to think. We know from here to here is 12 meters long. So from here to here has a length of 12 meters, right? Because we have 12 meters as well here. This is a rectangle, so we know that the opposite sides are equal. Okay. We know from here to here is 16. That means from here to here is also 16. Okay. We also know that this length of x is uniform everywhere. So I'll have a length of x here, here, and here, etc. So we want to use this length of x in terms of the other sides to come up with an equation. So let's write these all out. We have x uniform all the way around, adding in all these extra pieces. Okay, well, I want you guys to think. If from here to here is 12, from here to here is 12, and I add an x on this side, and I add a length of x on this side, what's this total length? I have an x on this side, an x on this side, and I know that total length is 12. From here to here is 12. We know that length. Okay, well, if I have 12 from here to here, right, that length from here to here is 12, and I have an x here and an x here, I have 2x plus 2x. So I have 12 plus 2x. That makes up this entire length. Now, I am going to clean this up a little bit because I just don't want you guys to get confused with the amount that's written on the paper here. All right, now that I cleaned up our picture a little bit more here, I only kept our essentials. Now we want to look at this length here. We want to figure out what's that total length going to be. Well, let's take a look. We have, let me just make some room here. We have the length from here to here is 16. We know that. And the length from here to here is x, and from here to here is x. So I have two x's on either side of that 16. So when I add them all up, I get 16 plus 2x to be that other length. Because really, that length is this entire length right here. That's 16 plus 2x from here to here. Now that I have my length and my width for the entire garden and walkway, we can write our equation. Because if you remember, area is equal to length times width. I've got a length, I've got a width, and I know the entire area is 396. So let's write it out. Area is 396 meters squared, which equals my length of 16 plus 2x times my width of 12 plus 2x. Okay, that's our equation. Done. That's an equation. Now, the next piece says, describe how your equation models the situation. So describe how your equation models the situation. Okay, well, we know that the 2x plus 16 represents the length of the walkway and garden. In addition, we know the 2x plus 12 represents the width of the walkway and garden. Okay, and then the entire area, that 396, represents the area total. So now, our next piece says, determine and state the width of the walkway in meters. So now we actually need to solve for the walkway. And now remember, we said the walkway is x. So remember, the walkway is x. That's this piece right here. We're trying to find x. Find that width of the walkway. Okay, well, we have our equation. 396 equals 16 plus 2x times 12 plus 2x. All right, well, the common sense thing to do here is now to distribute. So we're going to distribute, double distribute. 16 times 12 is 192. 16 times 2x is 32x. 2x times 12 is 24x, and 2x times 2x is 4x squared. Just double distributed. All right, now we want to combine like terms, and the only terms that we can combine are the 32x and the 24x. So let's combine those like terms. We will have 396 is equal to 192 plus 56x plus x squared. Now, you should recognize what kind of equation this is. What kind of equation is this, guys? It's a quadratic. Why is this quadratic? Because of the x squared. The degree is equal to 2, so it's quadratic. You gotta know that. Okay? All right, and how do we solve for quadratics? What do we have to do? Good. We got to set it equal to 0. So we're going to subtract that 396 on both sides and combine our like terms. 192 minus 396 is negative 204. We bring down the 56x, and we bring down the x squared. Okay, I am going to erase what I have on the page just to give us some more space here. And I want to get this into standard form. But first things first, let's erase what we got so that way we can clean this up and solve. So make sure you have this all written down. All right, so let's write down our equation that we had from before. So we had that negative 204 plus 56x plus 4x squared equals 0. And now we want to write this in standard form, so we got to rearrange our terms. Remember, standard form is ax squared plus bx plus c equals 0. So we've got to move this term out front. I have 4x squared plus 56x, and move that negative 204 over to the back. Awesome. Okay, now we can solve this quadratic. We have everything we need. It's written in standard form. How do we solve quadratics, guys? There are 3 methods. What are they? We've got quadratic formula, we've got factoring, and complete the square. So again, I'm going to do this with factoring. What is the first thing you do before anything? Before any multiplying to the back, split the middle, etc. What's the first thing you do? You got to take out that GCF. Take out the GCF. And the GCF in this case is 4. So I'm going to divide everything by 4. The reason why this 4 is now going to disappear is because I have an equal sign and it divides out. Everything divides out by 4. So we have 4 divided by 4 is 1. We leave the x squared. 56 divided by 4 is 14. Negative 204 divided by 4 is negative 51, and that's all equal to 0, because 0 over 4 is just 0. Okay, now let's factor. Again, guys, you should be using your calculator to factor this, because I don't know off the top of my head what multiplies to negative 51 and what's going to add to 14. So use the calculator trick I showed you. I'll write that here on the side. We have y equals what? Remember? Do you remember? We have y equals negative 51, and we're dividing it by x. I believe I had a small typo in my other video. It's divide by x, not x squared. If I wrote x squared in the other video, please disregard that. Okay, so we're dividing it by x. Okay, so I'm going to look at my table with you guys. So let's pull up our calcs. So I have, when I type this in the calc, when I make my table for x and y, let's see what we got. All right, so I wrote out a list of numbers here. I just went 1, 2, 3. So we have 1 times negative 51 is obviously negative 51, but that's not going to work because it's not going to add to positive 14. 2 and negative 25.5, that's not a whole number. We're not dealing with that, not an integer. All right, now let's take a look at this here, that 3, negative 17. Well, negative 17 times 3 is negative 51, but when you add them together, I get negative 14. So these just need to be flip-flopped. This should be negative 3 and positive 17. That's going to work. Because if we check 17 minus 3, so 17 minus 3 is going to be 14. So there's our combo right here. So let's factor it out. I've got x minus 3 and x plus 17. We're allowed to double bubble because that leading coefficient is 1. Awesome. All right. Let's t-chart. And you guys can solve for x. So I'll get x minus 3 equals 0. And we have x plus 17 equals 0. And now we're just going to t-chart. So we're going to add the 3 on both sides. We'll get x to equal 3. And then subtract the 17 on both sides. We'll get x to equal negative 17. All right, now you guys got to go back and read. The question says, to solve for the width of the walkway. You should recognize this answer makes no sense. You can't have a negative length. So the width of our walkway is right there. It's 3. X equals 3. And let's just make sure we include units. So the width of the walkway, is 3 meters. There you guys have it. All right, let's just take a look at one more problem and then we'll be done for the day. All right, so I'm going to flip over to the next page. I want to look on page 32. This is the last question in our packet, and then we're done with this unit, and we'll be moving on to something else. All right, so we have Sam and Jerry have ages that are consecutive odd integers. What does that mean? Name me some consecutive odd integers. Okay, we could have 1 and 3. We can have 5 and 7. We could have -5 and -3. These are all consecutive odd integers. Okay, so these are just some examples. We have the product. Product, what does product mean? You guys got to know product means multiply. Okay, we're multiplying here. The product of their ages together is 783. So again, we have Sam and Jerry. Their ages are consecutive odd integers. Well, in this scenario, their ages can't be negative. So we know this ain't going to work, but those are just examples anyway. All right. And we have the product of their ages is 783. So we know we're going to multiply two things and get 783, right? If Jerry's age is represented by J and Sam's age is represented by J plus 2, write an equation. So we're going to write an equation. Equations have equal signs that could be used to find Jerry's age. Well, we kind of already have all the information we need. We're just going to be multiplying, hence the word product. We're going to multiply Jerry's age, so Jerry's age, which is J, and we're multiplying it by Sam's age. We're just multiplying these things, guys. So we're going to write, we have J plus 2 times J. Just write the equation that could be used. Now, if we actually want to solve this equation, so here you're actually done. It just said write an equation. If I want to take the next step further and actually solve it, well, let's do it. I have J plus 2 times J, which equals 783. We distribute that J, so I have J squared plus 2J equals 783. Again, you have to recognize this is quadratic because the degree is 2. Whenever we solve quadratics, you got to set it equal to 0. Set it equal to 0. There are no like terms here, none, so we're going to rewrite J squared plus 2J minus 783 equals 0. Again, just to give us some practice with our factoring, I'm going to factor this. This is a trinomial. There's 3 terms, so let's factor this trinomial. The leading coefficient is 1, so I'm just going to double bubble. Okay, we're going to double bubble. All right, so again, be careful of the variable here. We're not using x's, we're using j's. All right, and we got to think, what multiplies to negative 783 but adds to 2? Oof, yikes. All right, well, I'm going to type this into my calc. I've got y equals, I'm going to type in negative 783 divided by x. So type that in the calc. Look for that list of values from the table. So when I look at my table, these are some of the values that I see. All right, so these are some potential options. Now let's think. Negative 87 times 9 is not going to add up to 2. So this is out. Let's look at 27 and negative 29. Well, we know they multiply to that negative 783. But now when I add them together, what's negative 29 plus 27? That gets us negative 2. And I want positive 2. So guys, you just got to flip the values. This should have then been positive 29 and negative 27. So that way when I combine my terms here, I'll have 29 minus 27 is 2, which is exactly what we want. So there are your factors, plus 29 and minus 27. Because this question could have said solve for their ages. It could have. Again, we're just going to t-chart here. I have j plus 29 equals 0 and j minus 27 equals 0. Subtract that 29 on both sides. So I have j equals negative 29. Add the 27 on both sides. And I have j equals 27. We reject the negative answer. You can't have a negative age. So we know that j is equal to 27. If the question said find Sam and Jerry's age, well, we know that Sam's age, if we could just go back and read, Sam's age is j plus 2. So Sam is equal to j plus 2. So if I wanted Sam's age, his would just be 27 plus 2, which is 29. And we know Jerry's age is 27. All right? Hope you guys found this video helpful. Again, this was the last one that you were required to watch before your quiz on Friday. All right, as always, let me know if you guys have questions. I miss you all. Hope to see you soon. All right, bye.